All right, guys. Part of solving equations with square roots that popped up in class is we've got to talk about what to do when you get an answer that doesn't work out cleanly. So, for example, if I get something like x squared equals 50, well, I'm going to take the square root of both sides. And you notice I've made a little perfect square list over here just kind of to help me out. 50 is not a perfect square, okay? It is not a perfect square, so it's going to be very hard to take a square root of something that doesn't work out. We know it's roughly 7 because 50 is close to 49, but it's not a perfect square. Square roots need a perfect square. Okay, they don't work out cleanly unless you have a perfect square. And honestly, we want nice, clean answers in this situation. So the way we're going to handle this is we're actually going to look for a factor of 50 that is a perfect square, okay? In essence, what we're doing is we're saying, okay, 50 isn't a perfect square, but is there a perfect square hidden within 50? So I scanned my list of perfect squares, and I know it's not going to be anything above 49, right? Because 64 doesn't multiply into 50. And I'm going to scan and see, and I notice that 25 is the highest number that I've got, and I'll talk about that highest number situation in a minute. But 50 will break into 25 times 2. Okay, so this is the same exact problem. The square root and squared is going to cancel out. So I could say that x equals the square root of 25 times 2. It's the same thing as saying the square root of 50. It's just I've broken it apart. Now, exponent laws tell me that if I'm taking the square root of 25 times 2, I can kind of distribute this square root. And I can say, oh, so that's the square root of 25 times the square root of 2. I've just distributed the square root symbol. Well, this is helpful because I can actually work out the square root of 25. The square root of 25 is 5 because 5 times 5 makes 25. And it's a positive and negative. That was explained in the last video. Then you go, okay, well, what's the square root of 2? I don't know the square root of 2, so I'm just going to say it's 5 times the square root of 2. So you're breaking it into getting some of it, at least, as a square, as a perfect square that you can work out. But it just may not work out to be everything. So if I do this on the calculator, just to kind of prove to you that these two things are equal. So let me get where there's not a glare on it. But you can see I worked out the square root of 50. And I've got this decimal, and then I just got the calculator to kind of extend that decimal for me to get 7.07. It's a big, long, nasty decimal. It actually keeps going forever. Well, 5 times the square root of 2 actually works out to be that same exact decimal. Sorry, that was a mix-up where I accidentally hit squared. But so they are equivalent expressions. They're both a little over 7, which makes sense because the square root of 49 is 7, so we're a little higher than that. But this is just a little bit simpler answer version than going with this big, long, nasty decimal. Okay, so that's what we're doing. So if I look at x squared equals 300, I'd be taking the square root of both sides. And so I'm going to say, okay, I need a perfect square that goes into 300. So I always say start at the bottom of the list. Okay, I know it's not going to be anything higher than 300, not 289. I start looking for what multiplies into 300. And I can say, well, let's call that 100 times 3. Okay, I need a perfect square. The mistake that some people make sometimes is they start looking at 50 and they want to say, oh, well, I'm going to break 50 into 5 times 10. Okay, we remember that we need to break it into factors, but neither of these are perfect squares, so those are kind of useless factors in that situation, okay? We need perfect squares. We need numbers off of this list over here. That's why we went with 25 and 2 instead of 5 and 10. So 100 times 3, I'm going to go ahead and distribute my square root right there. Again, I'm kind of sometimes I get lazy. I don't like rewriting things, but I am still going to show that step. Then I say, okay, well, the square root of 100 is positive or negative 10. The square root of 3 doesn't exist. It's not a perfect square. It does exist. I shouldn't have said that. It's just nasty. So I'm going to leave that as the square root of 3. That's all that is to it. So if you can't take the square root of 300, 300's not on the list, I'm going to look for what perfect square is inside of 300 that I could pull out of it. If I take x squared equals 72. I couldn't see my example over there. I'm going to take the square root. 72 is not on this list. It is not a perfect square. So I'm going to look for a perfect square that goes into 72. Start biggest and start working your way down. And pause it if you need it. But you end up with, okay, so I can call that 36 times 2. Take the square root of both of those. And the square root of 36 is positive or negative 6. The square root of 2, I can't work out. So that's what I've got. One issue that popped up in class with this specific problem, the 72, is I had some people that were looking at their list of perfect squares and they said, well, 72, 9. 9 goes into 72. I'm going to call that 9 times 8. That's not a bad list of factors, okay? It's not like the 5 and 10 we talked about up here, because 9 is a perfect square. I'm going to distribute my square root, and I end up with positive or negative 3 times the square root of 8. But here's the issue with 8, is there's a square root hidden in 8, okay? The issue is I can get a 4 out of it. So this is now 4 times 2. So I have the plus minus 3 that I already found. But now I've said, well, 8 can split into 4 times 2 because I've got this perfect square right here. I'm going to distribute it. And okay, I have the plus minus 3 that I already had. I now have the square root of 4, which is positive or negative 2, right? The square root of 2 does not have a perfect square, and it doesn't have any square factors in it. So the square root of 2, I can't do anything with that. Well, I have positive negative 3 and positive negative 2 that are being multiplied. That's where I get the positive negative 6. So see, it works out to be the same exact answer I found. It's just, holy cow, if you can skip straight to the 36, that's a lot faster than going through this and having to constantly look back, okay? If you break it down to a 2 or a 3, you're okay. There's no perfect squares hidden in a 3, so you know that you're done. But if you end up with one that does have, you know, like the 8, where then all of a sudden you're having to say, okay, well, wait, 8 can break down further. That's where you have to be really mindful of that. We can combine this with what we were doing yesterday. If I start looking at an example like x squared plus 5 equals 103, okay? In this situation, I'm going to do the same thing I did yesterday, where I'm going to solve PEMDAS backwards. So I'm going to do the addition and subtraction first by subtracting 5. I get x squared equals 98. There's no multiplication division, so I'm going to do the exponent next. The inverse of squaring something is to square root. And that's when you say, okay, 98 is not a perfect square, so I'm going to have to go figure out which one of these perfect squares is in 98. I always say start at the top and work back. It's the ways that you can avoid having to do those multiple steps. So if you don't know, go off on the side and do some math, but it ends up being 49 times 2, okay? And so the square root of 49 times the square root of 2, x has to be positive or negative 7 from the 49, and then square root of 2 stays square root of 2. One more. If I go multi-steps, equals 18. Then I'm going to subtract the 6 to get 12. Then I'm going to divide by the 2 to get x squared equals 6. Take the square root of those. 6 is not a perfect square on my list, so I'm going to look over here and see, okay, well, are there any perfect squares that go into 6? Really, my only options are 4 and 1 is kind of useless because the square root of 1 is just going to get me a 1. But 4 does not go in, so this is like the actual best case scenario. I can't work out any of it, but I do know that there's a positive and a negative option on whatever the square root of 6 is. Okay? So, there you go. It's all about looking for perfect squares. When you don't see them right off the bat, you've got to find where they might be factors of the number you're working with. Okay?